Of all the planets in the universe, Earth is surely the best suited for life. You're wrong. In a few minutes, you will learn about what world scientists have discovered that may be even better for life. Math, physics, and astronomy are ruthless things, if only because these three sciences claim that it is possible for there to be planets in space that are better suited for life than Earth. Back in 2014, Heller and John Armstrong introduced the notion of a super-orbiting planet, defined as a celestial body possessing characteristics enabling it to sustain a richer variety of flora and fauna compared to Earth. How could this be conceivable? Well, the key may lie not so much in scrutinizing the planets themselves, but rather focusing on the stars they orbit. Our Sun, a typical G-type star's yellow dwarf in the main sequence category, has provided us with the ideal conditions for life to thrive. Nevertheless, it's worth noting that stars of the K-type stars variety, known for their cooler temperatures, hold the title of being the most nurturing and supportive stellar hosts for their planets. It's not just about temperature. Living on a tiny brown dwarf is theoretically possible. Star temperature primarily affects the habitable zone size. What truly matters for an ideal star are its activity and lifespan. Our Sun, a compromise between large and small, hot and cold stars, isn't perfect due to its relatively short lifespan. The Sun is already 4 billion years old and will become a red giant in about 1 billion years, extinguishing life on Earth. Mars may briefly enter a habitable zone, but its fate is sealed due to the Sun's expansion. In total, a star like our Sun allows for 5-6 billion years of potential life. While that seems substantial, remember that it took 3.5 billion years for single-celled bacteria to evolve into humans. This is where K-type stars become important, as they are calmer and can endure for 40 to 70 billion years. Life around such stars would have ample time to evolve without facing global catastrophes. Another drawback of G-type stars like our Sun is their instability, leading to phenomena like ice ages and global warming. Just a few tens of thousands of years ago, glaciers reached central Germany, but this didn't significantly hinder the diversity of life. In contrast, life around K-type stars would be more resilient to stellar fluctuations, potentially evolving for tens of billions of years. Adding to the appeal of K-class stars is their abundance in the universe. While stars like our Sun make up only 6% of the Milky Way's total, K-type stars constitute 13%, providing a higher likelihood of hosting life. Size also plays a crucial role in planetary science. If Earth were 10 times larger, the pressure within its liquid mantle would increase significantly. The iron in its core would freeze, causing the magnetic field to disappear. Instead of the northern lights, we might witness people suffering from radiation exposure. Additionally, the planet's increased size would attract more asteroids, leading to frequent impacts. The greater mantle volume would result in heightened volcanic activity, making life less diverse and challenging to model accurately. On the other hand, a smaller Earth presents its own set of issues. Lower gravity also weakened the atmosphere's hold on the planet, a problem we currently face. In 2009, NASA calculated the rate at which Venus, Mars, and Earth were losing their atmospheres. And the surprise was that the Earth is losing it fast. To be more precise, about 90 tons of substance is going away every day. Comparing with Mars may not be entirely accurate due to its smaller size and significant atmospheric loss. However, there is a middle ground between extremes. A planet that's 1.5 to 2 times heavier than Earth offers several advantages. Firstly, it provides twice the gravitational force, leading to a denser atmosphere. This denser atmosphere would naturally reduce solar radiation, resulting in benefits such as erosion and smoother terrain. Shallower oceans would foster increased diversity of marine life, as it's easier to thrive in shallow waters. While tectonic activity might increase slightly, the vast expanses of habitable land would easily compensate for it. A planet with ample land, a denser atmosphere, and a slightly higher temperature enriched with oxygen, does sound like a paradise, although life on it would need to adapt to the stronger gravity. It's worth noting that according to scientists, the benefits of planets slightly larger than Earth tend to outweigh the drawbacks. Another factor that could make a hypothetical exoplanet superior to Earth is the presence of a greater number of continents. Throughout Earth's history, when it had a single supercontinent like Pangaea, the central regions were often sparsely populated deserts due to their distance from the ocean. This pattern has repeated with other supercontinents, leading to areas like the Gobi Desert in Eurasia and the Sahara in Africa being relatively inhospitable. Small continents would minimize the distance from the ocean, promote numerous currents, and foster overwhelming biodiversity. Isolated regions like Australia showcase the unique species that can evolve in such conditions. In the world of survival of the fittest, placing life farther apart increases the chances for weaker species to survive and evolve into fascinating forms. Humanity, in its pursuit of a better world, has dedicated countless scientific articles and invested billions in the search for an ideal planet. However, the quest has yielded mixed results. In 2020, Dirk Schultz's highly publicized article highlighted 24 potentially super-habitable planets with conditions better than Earth's. Upon closer examination, it became evident that 23 of them did not meet the anticipated criteria. Since then, progress in the search for habitable planets has been limited. Scientists predominantly rely on mathematical calculations involving factors such as orbits, planetary masses, and hypothetical atmospheric compositions. However, as we've discussed, life is delicate, and many variables can disrupt it. To confirm the existence of super-Earths, ironclad evidence is required. One of the top contenders is Kepler 442, meeting most of the criteria we've outlined. Firstly, Kepler 442 orbits within the habitable zone of a K-type star, which is approximately 40% lighter than the Sun. Although Kepler 442 receives about 30% less heat than Earth, it compensates for this with its significant size advantage. Kepler boasts a 30% larger radius and is roughly twice as heavy as Earth. Indeed, Kepler fulfills the criteria of a dense atmosphere, shallow oceans, and ample room for life. The greenhouse effect resulting from a dense atmosphere could potentially offset the difference in heat received, making Kepler 442 the most promising candidates for harboring life. However, it's crucial to note that Kepler is located 1206 light-years away from Earth. While the James Webb Space Telescope may theoretically provide a closer look, our current communication and spacecraft capabilities may hinder prompt verification. The silver lining is that K-type stars like the one Kepler 442 orbits have longer lifespans than Earth, offering ample time for future generations to investigate. Another candidate for potential life is the Trappist star system with 4 planets in its habitable zone. Among them, Trappist 1e stands out for its physical similarities to Earth, piquing the interest of scientists. Trappist 1e shares many similarities with Earth in terms of mass, radius, gravity, density, and temperature. However, the challenge lies in its host star, which is significantly cooler and smaller than the Sun. As a result, Trappist 1e orbits much closer to its star, with a year lasting only 6 days and constant radiation exposure. Yet, if life somehow adapted to withstand these conditions, it could persist for billions of years. Thus, Trappist shouldn't be ruled out as a potentially habitable planet, especially given its proximity to Earth at just 40 light-years away. And the James Webb Telescope will definitely have a field day with this system. Our understanding of life remains limited. We've built bombs capable of wiping out cities, but we can't even create the simplest single-cell life. That mystery is still unsolved, and any analysis of planets relies heavily on our observations of Earth. Space is vast, and life might exist in forms we cannot fathom. Will scientists of our generation find extraterrestrial life? Share your thoughts in the comments and don't forget to subscribe. That's all for now. See you later, friends.